is I've created, and I haven't been able to do it this class yet because the last time I recorded, I forgot to run sound. I forgot to turn on my microphone, so it's just my screen. But I'm after class tonight, and it may not get done till tomorrow because it takes a long time. But I'm going to break the class up into about 3 short videos, 40-minute videos, and upload it onto a private YouTube channel so that if you don't want to watch it via the UJA and you'll be able to see the full size screen, you can I'll put the YouTube link on Blackboard, and I've already I think created a file for it somewhere here. Laptop class recordings right here. You probably can't see it because I don't have anything in there yet. I attempted to put some stuff in there, and then I realized there was no sound to it and how that wouldn't be very helpful. So let me dig out. We're going to just finish at least the first op of the spring housing, finish programming that. We'll see where we're at there, and then we'll dive right into the pretty extensive homework. In fact, we'll take a little sneak preview at it, and you'll kind of see why. So if you remember right, this is like 6 pages ahead. So if you want page 98, you got to go 104. Enter. And let's see here. 96. I was close. I must have picked up the wrong page number. 80 and 81, sorry. I was still stuck on this 98 points thing. Go back to... Okay, so from here, I can probably just scroll up about 20. 78. So this is... See all that? That's like 100 points. So kind of what we're doing is very, very pertinent to what all this is. Because, yeah, I imagine this will take you guys a little bit of time to do. My idea is to have, since this is technically supposed to be an 80-hour class, is to have 2 hours of time where we're programming together and then give you hopefully less than 2 hours of homework. Hi, Sarah. And trying to give you your best educational value for what we've been here, so to speak. So, got my spring housing copy of the program that we wrote last year, actually. And also, if you weren't here last week, enrollment is open on Monday. I know that sounds weird because it's like, why would I want to enroll in computer virtual college? But they are planning on having summer classes, and they are planning on having fall classes. I've got 2 classes scheduled. The only difference is they're going to try to cram everything into the first 8 weeks, which is going to be pretty tough for everybody. But so I'll be running CNC lathe class on Thursday and Friday evening, and the advanced mill class will be on Saturday for 10 weeks. So the lathe class will be 8 weeks and just 2 nights a week instead of 1. But that's the only way they would do it. Yeah. So let's look at where we're at with our spring housing. Many of you turned in your homework. You did a really good job. If you did turn in your homework, I probably made some comments and got back with you on that. If I haven't, send me an email or a text and remind me. My system of remembering that is not deleting your email until I get your homework looked at. But I didn't apply any points to the homework until the part is all programmed and done. So we look at our drawing. Let's see, where's the drawing? I don't think I have the drawing pulled up. Got the lap. We could use this one. So we'll go bar puller project. We'll just open it up here. Let's see. Spring housing. Perfect. So this thing is going to be worth the same amount of points that it would have been if we were actually to make the part. So obviously I won't be checking the dimensions, but this program is worth 100 or 92 points. So it's important to get it turned in. Like everything else, is pretty much due at the end of the semester here in about 4 or 5 weeks. I think the 5 weeks from now is actually the final exam. So that'll be a thing where we just kind of log in, and I will make the final exam available, and then I'll log out. I don't expect everybody to be online during that, but it's pretty much due at the end of the night by like 10 o'clock. You can probably take a screenshot, or we'll talk about that later. But so as far as where we got with our programming, kind of got rabbit trailed there. Weekly homework. Spring housing first half. I thought I opened that up. Okay, this is, yeah, I don't need that because I copied it down here. I'm getting myself all confused because I got too many tabs open. So bear with me a little bit. And we'll get rolling here. Don't need this tab. I meant to bring my phone calendar down here because everything that I have is in there, but we'll be here next week for sure. And I think the week after that is going to be recorded. So, oh, I know. I clicked on the points for the spring housing. That's what bar puller project. Also, feel free to chime in if you have any questions or comments about anything.
Hey Addison, what kind of classes I have in the summer for like machining and
Not a lot. Not a lot. What you can do is if I log into my student account, kc.edu, you can pretty much just do a class search by term. So that's my student account. I'm actually taking educational psychology this summer. Yeah, so I can be a better teacher. So you go to your class schedule, or class search, and then you can pick the summer is up now, so you can continue. I'm already registered and everything. Oh, oh, here we go. So search for classes and everything that is related to the machine tool. Well, I'm not sure, what path you're on, but if you're interested, here's how you can search. You can say, this is all the available course flows. We are SIM, and you can search SIM. You can search campus, which is probably going to be BT, and then all term and campus. So that'd be 2020 summer, course subject, SIM. I don't know why it blasted me out of there because I thought term and campus. So anyway, that's where you would launch to see what's available. Business technology, term, campus, search. And so here's our 2020 sim. It looks like machine shop safety, basic lathe, basic mill. Not a lot. These classes are pretty much geared towards UMKC. They're like 3-week mini sessions, as I recall, because I used to teach those on Friday. So you want a quick mill or lathe class, you're welcome to sign up for those as well. So that's kind of what's going on in the summer. But you can search all your courses. I'm doing educational psychology because I'll get my associates this semester, and I'm going to start working on a Bachelor of Science in Occupational Education. So
Cool.
yeah, I'm enjoying it. So all right, let's get into programming the bar puller project and the spring housing. Don't tell me I deleted it. Spring housing. Oh, here it is. Whew. All right. So far, if I remember right, we have got not a lot done. We faced it. Now, one thing I was noticing some of you guys were doing was on this Y move up here. It looked like you were programming the middle of the 1.690 dimension. In fact, I saw a lot of Y mine, and I didn't particularly comment on it because there's enough people doing it that I wanted to kind of talk about it. 1.690 divided by 2. But yeah, I saw a lot of Y minus 845s. And so what the deal is this material is still 1.750 before we start cutting on it. So while that's not wrong, if you wanted your cutter right dead center in the middle of the part, it would be 875. Y minus 875, pretty sure. Let's see, 1.750 divided by 2. Yeah, 875. So that would have been more, having your cutter right in the middle of it. And then we got our 3/8 spot drill out and drilled the holes on top. And everybody that submitted homework did really well with that, and really all of this. And then we got to our 3/4 drill, and we got to Z minus 1.150. I think it was Jeremiah, pointed out that I did not have that I was missing something. It was like a feed rate or something. Don't exactly remember, but or maybe that was the lathe class. So now it's time to see. We drilled and tapped our holes, and these 6 holes. And we drilled these out. So now it's time to break out our end mill and circular interpolate these holes and mill around the entire outside. And I really like milling around the outside of the whole part, because that way you know that as long as your program's right, that your holes and everything are going to be centered within the contour just perfectly. So let's see, what do we do for X and Y position? I was looking at this last night, but I was more looking at the process. So in other words, even though we're milling around this outside, we want to mill it just past this step for depth. That way, when we turn it to this view to mill this step and drill these holes, the only thing that'll be left on the outside of the part is going to be just a little bit of material right here on both sides. And so what we end up doing is on our 3rd operation, when we mill this slot, drill the 2 holes and tap the holes, we also come through with the end mill and try to carefully blend this little bit of material in with the rest of it that's been milled, if that makes sense, because there will be a line right here on both sides where there's just a little bit of material left. Okay, so that's how we do it in 3 ops. And usually I leave this raw material. It's optional because that's where that bar is going to clamp, and once it's fixed in the machine tool, you will never see that surface. So if you're going to have a raw material surface, that would be a good choice. Okay, so we need to pull out our end mill. I guess I'll tile my screens here. This seems to work the best. side by side, and everything kind of goes haywire. It seems like when I have my program over here, it's better because I can make my screen smaller here. And that one, that's Mastercam. And then we'll get this up and going here. And no, that's not what I want. This one, hiding in behind. There we go. That way I can kind of bounce back and forth between the class and the program. And if we want to, we've got Mastercam, but right here our program's all ready to go. And again, if this does anyone having any issue with seeing my screen or hearing my mic? I guess if you weren't hearing my mic, you wouldn't be able to answer that because you wouldn't be able to hear it. But just know that I have some people in my GD&T class that I attend that have connectivity problems in and out of class. So not only will I post the UJA video, but I'll also post my screen recording of it. So you're all like, get on with it already, right? All right, so what we need to do is, next thing we need to do is determine what size end mill we're going to use to cobble these holes out in a helical way. By helical, I mean we can do a circular interpolation where the end mill's making a circle in X and Y and also moving in a Z minus way. And this is a really great way to remove material out of a bore because you don't particularly need a center cutting end mill to do this because it's doing kind of a ramping feature, except it's in a circle. You do this all the time. It's a lot easier with Mastercam because you basically click the helix bore tool path and a couple mouse clicks and you're done. So this will be a little bit more involved, but you'll get a good gist of how this is going to work. So let me enter this up, and we'll just start our next tool. And since these bores are 1 inch, I'm going to say the logical thing to do would be to use a 3/4 inch end mill, like a 3/4 inch finish end mill. If you're not familiar with what an end mill is, try to remember way back at the beginning of the semester when we were cutting around the outside of different parts, the cam arms and things, we would use a hog mill to rough it out. And the hog mill would have a serrated edge on it to be able to take a full cut, a full depth cut. And the serrations on the hog mill are designed to reduce vibration and chatter. So then we go through it again with a finish mill and to clean it up in one pass. So since we don't have to find 3/4 inch end mills, we'll just go ahead and program a rough pass and then a finish pass, maybe just one circle. So cutting circles is pretty fun and it's really pretty easy also. One thing we didn't get done last week was because I did not have my Mastercam file up, was we didn't figure out what this dimension is. So it doesn't really matter right yet because we do have the depth of the counterbores, or the bores, where the springs will actually go if you ever get around to making this part. So, but it does extend. The reason it extends past the bottom of this step is so that the pistons that we put in there will actually be able to be pushed up in there. They'll be putting pressure against the cam arm. So that's kind of a critical design element, that this bore extend past that step. All right, so let's just go with, see what tool are we on? T6. Oh, forgot my caps. T6, M6. So this is just going to be a 3/4 inch finish mill. And pretty much start every tool path out and end every tool path the same way. You have to call up the tool offset. You got to turn on the RPM. A good way to think of it is like, what does this machine need to know? So I don't get lost, I'm gonna have a little place where I can move my scale down here. Because honestly, when you're writing programs in industry, you'll just take, instead of just typing out every single line, you will take groups, paragraphs of toolpaths and move them around and then just alter the different geometry that you're needing to program. So let me see if anybody's got any questions yet. No. Not sure what that's a response to, but oop. Probably don't really need this tab either. By the way, that pink bell up in the UJA corner is a great way to log in. You go just click on the UJA lectures and that pink bell pops up on the day of class and you can launch it off of that. Looks like most everybody's here. Okay, so we'll start our program, our roughing. We're going to rough it out because you almost always have to take a rough and finish pass. So we're going to say rapid G0, G90, absolute. I think we were using G54. And we want to position X and Y next. So let me pull up the thing here. And if I remember right, all I know what I was going to do is going to look at where we were taking our zeros from. Center apart, back apart, top apart. So, oh, I remember we decided if we were going to take our edge finder, but see, if you want to leave this raw material, you can. So that way, if you made this exactly Y0, that would end up being raw material. If that makes sense. But I think we'll just program it to be Y0, and then that way, if you actually did set it up, that would be up to the setup person to make sure and move that Y in the minus 20 or 30 thousandths so that would actually be a cleaned up finish if you wanted that. There's plenty of material for it to be cleared up all the way around. So, all right. We always want to position X and Y before we move Z. And those positions were plus and minus 562.5, if I recall, because we took 2.250 between these two, divided by 2, which gives us 125 from the center from here to here. And what we have to do to find out what these two are is divide that by 2 again. Gives us our 562.5. From here to here is 562.5. There's the same. So X. Kind of try to make it a practice to do the features that are closest to machine home first. Not any big deal particularly, but if you think about it, if I was to wrap it here, then go to this hole, and then go home, it's really, I don't know, is it the same as far as travel? And it's not a big deal with these holes because they're closer together, but when you start programming something that's maybe 20 inches apart, you don't want to backtrack, wrap it all the way there and then backtrack. But I think at the end of the day, it's pretty much the same. I'm just kind of in the camp of always having a process of doing everything. So X, 0.5625. And then our Y, we also have to calculate because we don't know what the center of this is unless we go up here and copy it. That'd be a good idea to maybe review how we got that. So our overall part's 1690 minus 0.2. This 1.490, and then half of the 1 inch here be minus 0.5, 990. That's not what we told it last week, though, is it? X0 562. Oh, I guess we did. So redeemed. Got the right Y move. Thought it was something else. Y.990 or Y minus 0.990. And then we need to give it an RPM. And we can run pretty fast, but if we run too fast, we might end up having some chatter issues. So let's see what 600 surface feet looks like. 3.820 times 600 surface feet divided by 3/4 of an inch. It's 3,000 RPM. I think that's a little fast. So let's just go S1500 M3. I was in the camp of trying to be a little bit conservative. That way, people like if I don't get the luxury of proving in my own programs, so I don't want the machinists on the floor to feel like they're riding the dragon every time they pull one of my programs out, because it looks better on them if they're able to speed it up and make time, because they can say, hey, I got that program up to time and we didn't break any tools or whatever in the process. So it seems if some of you are used to seeing quite a bit higher RPMs and things, that's probably because, you know, sometimes it takes a while to get everything up to speed and full productivity. I've had other issues where I try to do things too fast and then I am told that things came flying out of the vise, and I'd rather they just speed it up on the floor. All right, so now we're going to call up our tool offset. G43, remember, calls up the tool offset. H6. And since this is we're only going to use one finish mill. And if we, because the other way is what I've been doing more of is where you use a finish mill to take smaller passes and just go around it that way, taking smaller step overs at a higher feed rate. H6. And probably the only other thing we're going to pull out is a chamfer mill after this. T7. And we're going to use cutter compensation so that when we do pull out our chamfer mill, we can use the exact same program. Remember how we were doing that with the cam arms, that we'd run around it with the hog mill, the finish mill, and the chamfer mill, all with the same tool path. And simply by changing the different the D values, you can run the same tool path, save a ton of time, and everything looks perfect because it's the exact same tool path. Okay, and then anytime we want to call up a tool length offset, it's a good idea to move Z, so you have a predictable Z movement. And a lot of programmers, I've worked in a lot of different shops, and it seems like everywhere I go, people wrap it to an inch above the part. And only allowed one M code per line with a Haas, so we want to take advantage of that and say M8. That way, if the coolant lines are kind of clogged on the way down, it'll give it plenty of time to turn the coolant on. I'm gonna control save. Oh, I didn't save this yet. So let's go find a home for it. That's advanced lathe. And go to MCC documents, CNC mill, and all documents. And I'm going to save it over. Oh, you know what? I saved it in the actual class because this isn't normal. So we'll save it in S20. Save. And yes, I want to replace it. Okay, perfect. Okay, so we're an inch above the part. We're on the right side bore, and we're right centered on the right side bore. And the smart thing to do here is feed down at a higher feed rate so that you don't have a production delay, but if you happen to change the tool and got your tool length offset wrong or something and walked away, that it wouldn't crash into it so hard. So we'll say G1 Z 0.1 F 50 inches a minute. All right. So remember, we have drilled these clearance holes out. So theoretically, if I was just to go straight down into that bore, all the way down to Z minus 1.050, I would be able to do so without burying the end mill. All right. So I'm going to do something a little fancy here. I'm going to ramp in Y and Z and turn the comps on all at the same time. So this will preclude us a little bit from using the total tool path for the chamfer mill, because we're not obviously going to be ramping down with the chamfer mill. So we'll say P41. At this point, as we're calling out G41, we're going to tell it the exact radius of the bore. And I'm going to go incremental here, G91. So now I don't have to really think about where I am from absolute. I know I'm in the center of the hole. And the other thing that's nice about this is once we get our tool path done and wrap it back out, we can just wrap it over to the other hole, copy and paste our helix bore that we're creating, and just do the other hole without having to reprogram it, if you know what I mean. Because we're in G91, everything will be great. The big danger here is we have to be sure we know where we're at in Z, because when we make incremental movements, so to do that, I think I'll do a simple, since we're at 0.1 above, I'll say G91, P41, turn on the comps, Y, so 1.050 divided by 2 is 0.525, right? Yeah, G91, Y 0.525. You can tell it, theoretically, the cutter is vanishing here, Y 0.525. And then I'm going to put Z right on top of the part. Z minus 0.1. So now the cutter is at the top of the part, and the Y and Z are both right at the very, very top of this part. If that makes sense. Okay, so we're going to do another little fancy thing here. Let's see, to go counterclockwise for climb milling, because the cutter's spinning like this, and we want it to climb mill all the way around that. So we'll say G, this will be your part of your homework. G dot dot dot. Figure out if you want to go clockwise or counterclockwise. And we're still in G91, remember. It's going to be a J minus 0.525 and Z minus, so each swipe will take 50 thou, okay? Z minus 0.050. Now here's a trick I'm going to teach you, is that you can give this code, this isn't going to be on any test or anything, but you can give this line of code an L value, and it will loop it as many times as your L that you give it. So since we're at Z0 now, even though we told it to incrementally move down to Z minus 0.1 because we were at Z 0.1, which is absolutely now Z0, we need to go 1.050 deep. Right, so this is going to be 1.050 divided by 1.050 will give us our L value because we want it to go minus 50 21 times. Will be at Z minus 1.050. L 21. So what that's going to do, it's going to corkscrew down and just cut that all the way down. And very lastly, wait a minute, we wanted to rough this and finish it. So we're going to have to, oh yeah, we do need a D6 for the 3/4 end mill. LL NVM. I don't know what that NVM means, but you're right. We need a D6. D6. I always forget the D's. So here, let's just tell it Y 0.521. All right. So when it gets to the bottom, we're going to give it one more spring pass. J minus. This also needs to be 0.521. Oop. Which we had the luxury of actually watching this run because it's really fun to watch one line of code do so much. Control save. I'm going to do one more J minus 0.521 to give it a spring pass. The other thing, no, we don't need an R. So how that works is if I'm at the top of the bore, remember how IJK works? From the start point of your arc to the center is your J value because you're in Y. And you tell it that from the start point of where you're at to the center of your hole is minus 0.521. But you don't give it an endpoint. It assumes that your endpoint is your start point. So that's why it goes all the way around and does a complete circle. If you only wanted to do a half a circle, you'd say, of course I'm wanting to go this way, you'd say G dot 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 J minus 0.521, Y minus 0.521 and put you at the bottom. But since you don't give it an X or Y value, it assumes that it's going back to the same start point being Y0 and X, wherever you're at there. So that's how that works. So we still need to take a spring pass. I'm going to say G40, turn the comps off, in absolute, or no, G40, leave an incremental Y minus 0.521. So even though you're telling it go 521 thousandths, it's only going the difference between 1.050 and the 750, which will be 1.050 minus 0.750. That ain't right. 1.050 minus, I must have did divide, minus 0.750 at 3. It's only going to move 300 or 150 thousandths, even though you're telling it to go 562 or 521 because of the cutter radius compensation. That makes sense. Do you have a question about any of these moves? It can be a little confusing. All right, let's go back and so now I want to go E41, and I'm going to go back up to, notice my Y value is plus up here. I'm going to go back up to my full diameter, which is going to be 1.050 divided by 2, which is 0.525. Y 0.525. And the beauty of this is now I'm going to, instead of helical interpolating, I'm just going to do one more pass at the correct value. I don't need to give it another D value because I gave it the D value up here. And I'm a fan of doing that only once. That way, if for some reason you change your tool number, you don't have to rechange the D number so much. So I'm going to take a recording